Now, parallel and perpendicular lines. We've talked a bit about this already earlier when it came to slope, and we're just going to reiterate it again. And again, we're going to say it comes down to slope. So, lines that are parallel, or lines are parallel when the slopes are equal or exactly the same. So it always comes down to slope, and that's it. Just slope. Doesn't matter about the points, but it comes down to slope. Perpendicular lines, or lines are perpendicular when the slopes are negative reciprocals of each other. So negative reciprocals, 1 over 2 is perpendicular to negative 2 over 1. Negative 4 over 5 is perpendicular, I should do the perpendicular symbol, sorry, is perpendicular to positive 5 over 4. And negative 2 over 3 is perpendicular to positive 3 over 2, and so on and so forth. Okay, so that represents parallel and perpendicular lines. Let's do a little bit of graphing here. Now we're going to go back to slope-intercept as well. So I've thrown some of those in there. Let's graph the function y is equal to 2 over 3x minus 5. Minus 5 is this point right here, 0, 5, sorry, negative 5. And we have a slope of 2 over 3, so we go up 2 over 3 to right there. And this will be the line, let's try to get it as exact as possible. So this is y is equal to 2 over 3x minus 5. Okay. Now, based on that, let's determine the function which goes through the point 1, negative 1. Sorry, I should put this point on here too. This is the point 3, negative 3. Okay, now let's find if a line goes through point A, which is at 1, negative 1 right here. So 1, negative 1, there's point A, and is parallel to this. Okay, if it's parallel, it means it'll have exactly the same slope. Rise of 2, run of 3, right here. Okay, so it's going to go to that point, 4, 1. And we're going to draw a line through there, if I can get my straight edge. Right there. And so this line right there is, in fact, parallel to this line. Okay, they are parallel. Now, we don't have an equation for this one right here. We're just told that they're parallel because they have the exact same slope. Okay, so these are same slope, okay, which is very important. Okay, the function which we would have would be y plus 1 is equal to our slope, 2 over 3 x minus 1. And sorry, I should have said that there earlier. We do actually have a slope, or we are actually asked to find an equation, x minus 1. Okay, so that will be the equation of that line. Now that is in slope point form because we're given a point and we're told what the slope is going to be. Now let's determine the function which goes to the same point, A, right there, 1, negative 1, but is perpendicular to this. Now if it's perpendicular, then the slope is going to have to be a negative reciprocal. So our slope is going to be negative 3 over 2. Okay, and our line will be y plus 1 is equal to negative 3 over 2 x minus 1. Okay, pretty much exactly the same as this one, except that now we have a different slope. So from here, okay, remember 1, negative 1, we're going to go down 3 and over 2 to this point right there, which is at 3, negative 4. Now I know we're really putting a lot of stuff onto this graph here, but that's okay. And this becomes our perpendicular line. Okay, y plus 1 is equal to negative 3 over 2 x minus 1. And now again, that's perpendicular to these two lines because the slope is a negative reciprocal of the other one there. Okay, so that's important to recognize that our slope is a negative reciprocal. Okay, and now again, the only thing that matters when it comes to parallel and perpendicular lines is the slope. Okay, it all comes down to the slope. Every single time, it's always going to be the slope. The other points or the other values on the line do not matter for parallel and perpendicular. It always comes down to that slope. Okay, either it's in front of the brackets here or if it's in front of the x value there. Okay, so that's the most important thing to take a look at.